Hello everybody, today I want to film a different type of video where I will be going through erosion, weathering and mass movement. We'll be covering the types of weathering and types of erosion, types of mass movement and the features of each one. Okay, so let's first focus on weathering. So to define what weathering kind of is, it is the removal of material that is in situ. So if we compare weathering and erosion is the transportation of materials, but weathering is the removal of material with the sort of base thing that's being removed from, for example, a cliff, like the removal of that material, for example, rocks off a cliff, but the cliff itself doesn't move. But erosion, if I'll just like quickly define it here, is just the transport of material from one place to another. So, for example, sediment on a beach through longshore drift. That's sort of the key difference between these two. So let's first of all go through the types of weathering. So the first one is mechanical. Mechanical, you'll probably also see it called freeze, thaw. And this sort of happens like this. Let me draw myself a little diagram. So first of all, what happens is there is a rock and water falls into this fracture in the rock itself. Then, this is like in the day, for example. It could be the other way, but I'm going specifically here. So, then, well, let me pick it up for sure, let's just do it darker. So then, let's say overnight, the water inside freezes, so this is now frozen, and it increases its size by 9%. This, therefore, makes the fracture bigger until, over time, this is like over and over again, this process of freezing and expanding happens until this rock breaks. And then this, for example, if this is a cliff and this is a rock, this will just fall down due to gravity. So that's mechanical weathering. Biological weathering is if we have our cliff. So we draw these little fractures inside. We have some flowers. These flowers have roots, and when these roots grow, push these fractures, pushes into them, which breaks the rock apart. So if we, let's say this is the end of the cliff and we have a nice little green leaf thingy there. This will cause, for example, this piece of rock to fall. Similar to how, like if you pretended this was the plant that's going in, sort of breaking that rock apart and causes it to fall. This can happen with plants, but it could also happen with, for example, some marine organisms which burrow inside, or creatures like, oh gosh, birds. Let me try and draw a bird. That is interesting. like little birds which burrow inside of the rock, and that also breaks the rock apart. This sort of weird dot thingy I've drawn, you can use it as an example. Epidox, I think, which are shellfish, which have adapted shells to drill through the rock by drilling through, and yeah, this all sort of leading to just rocks being torn apart, fallen, whatever. Hope that makes sense. The final one is chemical weathering, and there are different types of chemical weathering. I'm going to talk about 3 different types. So the first one is acid rain. So this is sort of, if we have a little plane here, what happens is our acid rain falls onto rocks such as, let's say this is limestone, and cause a reaction where this rain dissolves the rock around, and is characterized by these like sort of raised bumps in the rock. I think you could call this a subaerial process coming from the sky. It's not like biological where it's on the land, you know. So yeah, acid rain is just limestone that's eroded by this rain that create cracks in the rock, which breaks it apart. Another form of chemical weathering is oxidation, where the rock itself disintegrates when oxygen dissolves in the water and reacts with some of the rock minerals. This usually affects ferrous, iron-rich rocks. So Fe, I think, is the name for that. Okay. There is also one more that I wanted to talk about, so we're gonna do some little adaptation here. We're gonna remove attrition, which is carbonization. This happens when CO2 dissolves in rainwater. So let's draw ourselves a little water droplet and put CO2 inside. This creates a weak carbonic acid. This reacts with rocks such as limestone and chalk and creates calcium bicarbonate, which dissolves easily in water. Usually is more effective in cooler temperatures, as there is an increase in CO2 in water. Okay, so we've really pushed that into a little corner, but it is okay. Now we get to move on to erosion itself. So the first one I'm going to talk about is abrasion. This is essentially where you have a piece of rock, I don't know, and you get pebbles, which through the force of water, because you know it's really underwater, whatever, these pebbles grind against the rock, which is sort of makes this sandpaper effect. He smooths out this rock over time. Okay, so the next one is solution. It is when the sea itself reacts with certain types of rock, dissolves the rocks away. Then is essentially where in the water the rocks hit against each other, which causes pieces of them to break apart. We're gonna have to work around it. Oh my gosh. So then these pieces of rock break apart, and then these rocks consequentially get smaller. Okay, this is my idea. We're going to make a mini little thing for hydraulic action. So hydraulic action is, it is the sheer force of the waves on the rock itself, which break apart this rock and makes it fall. It's like if you had a wall and you had a hammer. Over time, you're going to break that wall, and this is sort of what's happening here. Water. Okay, so that's a little thing about weathering and erosion. Now let's get to the actual thing. The definition of mass movement is the downhill transfer of material acting under gravity. This represents a transfer of material and can be considered as an output from one store, such as the land, to another, and as another input to another store, such as the beach or sea. And this type of movement depends on a range of factors such as the angle of the slope or cliff, the rock type and structure, vegetation cover, and how wet the ground is. Water, water falls, fills this pore space that was before filled with air. This then causes something called pore water pressure, where there is now more force on the soil itself, that now there's water inside makes this soil more lubricated and leads to slope failure, which results in mass movement. It's rotational slip or something. So this happens on cliffs made of soft, unconsolidated material. For example, boulder clay. Usually happens on a curved surface or a curved slip plane. Sorry. This sort of thing happens when rainwater precipitation infiltrates the saturated and permeable clay. So the waves under this cliff erode the base through hydraulic action and abrasion, which forms this wave cut platform, as we said. Then this material, so the material of this cliff itself, falls down this curved slip plane and forms clumps of material on the beach. So the process can be sort of categorized as, it can be fast, but it can also take a long time. So I think that the time is variable and happens in wet conditions. An example of this is in Charmouth, in Dorset, or in Mapleton, in the Holderness Coast. Okay, the next one is a landslide. So I think there are two different types of landslides, and I'm going to try and explain both of them. I'm actually going to use this art page to explain landslides, but for wet is precipitation such as rain. The rain enters the permeable soil or material, which absorbs this water, right, which makes it heavier. And then it will reach this point, this layer of clay, which is impermeable, which means it doesn't allow water to intercept. So if we zoom in what's sort of going on here, this clay is formed of layers of something called mica. So there's layers of mica inside of this clay. So when it rains, the top part of the hill, as I said, becomes heavier, which therefore compresses the clay. This then becomes lubricated, which I feel like I've said too many times now, when the water collects on top. So it's like a nice little layer of water. Part of the cliff, or hill, whatever, falls down, basically as like a little slide. It slides down there. This usually happens fast, so when there's a lot of rain, and in wet conditions. Now, this sort of dry landslide, which also happens fast, is sort of when rock which is unsupported and due to, for example, earthquakes, through weathering such as like mechanical weathering, could be biological weathering, rocks that are unsupported fall down, pile here, which is called screep. And examples of this are in Jurassic Coast in Dorset, where in 2012 there was a situation where a sandstone cliff collapsed. A segmented rock breaks away from this cliff face and falls vertically or bounces down the slope. This is common in steep cliffs or cliffs composed of hard jointed rock, like limestone. And this happens because of mechanical weathering. So, sort of like in this diagram, where this part would fall down. An example where this is found is in Port Mulgrave in Yorkshire. So This is a fast and I suppose can be a dry or wet process. And yeah, I don't think there's much more to that. Next ones I'm going to mention are soil creep, characterized by these ripples in the soil, like trees and fences, also facing down. So this movement down the slope is under the influence of gravity, where the soil particles themselves expand and contract in wet and dry periods. So it goes from wet to dry, wet, dry, and that expands the soil. So when the soil is wet, the particles increase in size and weight, and they expand at right angles to the plane. But when this soil dries out, it contracts vertically, which results in this soil particle moving down the slope. Well, gravity always points down, right? But the net movement is down here, if we're really being pedantic here. The soil creep usually forms due to gravity and erosion. This process is very slow and happens in wet conditions. So solifluction, I think is a little bit difficult to explain, but I'm going to try my best. By these lobes here. This is solid or frozen rock. So this is the gradual movement of very wet soil down the side of a hill in very cold environments, and as I say, it happens over permafrost and it involves weathering processes. This is usually a fast and wet process. Okay, now mud flows. This soil becomes saturated through precipitation. Then over time, this saturated soil and weak rock flows down this slope. If the excess water cannot percolate through this rock, for example, then the surface layer becomes very fluid and heavy. Then at some point the slope fails and this saturated material made of soil, rocks and things flows down this hill and makes this mud slide flow down the slope. This often occurs after heavy rainfall from cliffs made of boulder clay or other unconsolidated material. An example of where this is seen is commonly at Mappleton and can also be seen in Hornsea on the Holderness coastline. So this becomes oversaturated and essentially all this mud that is created mixed with all of this flows down the slope and collects down in the lobe. This is the lobe, that's the name. Okay, so that is all. I'm going to put up this screen so that you can screenshot it or copy it down. So thank you for watching and sticking by. I hope that this wasn't too boring. I am going to be editing this a lot so that it's not just every 5 seconds. Next I want to plan to do a video all about waves. Yay, we love coasts. So see you. Thank you, bye. Because it's weathering.